Thank you. Good morning, everybody. You guys all doing well? A lot of you hangover from last night or not? Because I'm nearly there. I don't know how these slides are going to look up because this projector is actually quite bright, faint, yeah. So my name's Thomas. This is, I think, the third time I'm speaking at Securi-Tay, the third year. So I'm really happy to be back. I have a number of, I've been in the industry for a long time, and one of the things that I do is security architecture, but I also do a lot of incident response. And as part of that incident response process, you do a lot of forensics and investigations and things like that. So you come along, you go to a customer, or you're in a company, you're doing your forensics, you come to a site, there's no tooling on the machines. You're like, oh crap, what am I going to do? It's like, I don't want to install tools because if I install tools, I'm going to ruin whatever I'm looking for. So how do I do this? And then you just end up banging your head against the wall because you're thinking, oh shit, what am I going to do? What am I going to do? I'm sorry. I apologize in advance. There might be some harsh language in my talks because I usually get really passionate about what I'm saying and things just come out. So I said to myself, what am I going to do? Well, simple. I'm going to build a set of requirements. Part of my job is architecture, so I usually build a set of requirements. My requirements was that it had to be non-intrusive. I don't want to mess up anything on the disk or anything in memory, so I don't really want to change anything. I need to be able to quickly deploy it, because if I'm going on a site, I want to go get ready, do business, get ready, and just dump out information. And it has to be at a minimal cost. Because if you look at some of the toolkits that you traditionally use, like MKs and stuff like that, becomes quite expensive. So I wanted something easy to deploy and easy to use. So I also want something that I can use not only to do forensics, but that I could use to actually do investigations as well, a la threat hunting. So I'm big into threat hunting, and I wanted something that I could use even for just investigations before I go down into the deep dark hole of forensics. So I came up with this, PowerShell. It's like, wait a minute, it's on Windows 7, it's on most corporate installations, it's on all Windows servers nowadays. It's just there. It's like a really powerful tool. And why is it a really powerful tool? You'd be surprised. It supports regex, so I can do really complex searches across the disk, across the registry, for example, because you have built-in functionality that allows you to query the registry directly. So you can do like a dir HKLM, and you get the output of the local key machine. And then you can also add stuff to it. So you can build objects, you can create data stores, you can add things like DLLs and modules, and so you can extend it quite efficiently. But then I was like, oh crap, if I do that, I'm going to have to write a script, I'm going to have to install a script, and it breaks my initial principle is I don't want to change the disk. I'm like, okay, there's got to be a way to get around this. This is ridiculous. And thank you, our friends in Elite Hacksaw. This is a common technique for malware attacks, right? Where you're basically downloading a script directly into PowerShell memory and you're running it out of PowerShell memory. So I'm not installing anything on the disk. I was like, yes! Cool, I can do this now. So now I have a tool where I can actually pull down things, run them in memory, and I can start querying the system, which is really great. So, awesome start. So I've got a registry access. I can even access the event log with PowerShell directly. I got file system access. I can dump ACLs. I can dump alternate data streams with PowerShell. It runs in memory, so no disk changes. It's generally available on Windows 7, and lots of cool, useful scripts out there. So I started looking around, and I found Power Forensics. So I've been playing with this for quite a number of years now. It's been around, I think, for about 3 or 4 years. Essentially what it does is it gives you a full API to do your typical disk forensics. So you can dump the prefetch files, you can dump things like ADS streams, event logs, the caches, you can do a log to timeline with it. So this is really cool. Crap. It needs a DLL to be installed. I'm like, oh, damn. That breaks my one principle is I don't want to install anything. But, that's not going to stop me. So there is actually a technique in PowerShell where you can basically dump your file into as binary, put it into a variable, or download the DLL directly into memory like I did with the script, and you can run it directly from memory. So again, I win. I'm not installing anything on the disk. Yay! See, when you drink, you come up with ideas, not necessarily alcohol. So I have my foundations. I've got PowerShell. I can bring in scripts. I've got built-in access to things like registry, event log, and I can build objects and I can do things. So I can use it for forensics, and I could potentially use it for hunting. So I'm sitting here going, crap, what am I going to do? Now, let's go hunting for some ideas. So what else can I do with this, right? Because now I've got just basically scripted access and I want to do something more. So I discover Shrum. So what is Shrum? Shrum is Windows System Resource Usage Manager, monitor. I can never remember what it's, monitor or manager. Essentially, it was installed in Windows 8. It started appearing in Windows 8. And what it does is it monitors everything that process and network related that accesses the UI or runs in the UI. So it's continuously tracking what's going on in the system, right? It's part of the Diagnostic Policy Service. I am going to be able to talk this morning. Thank you. And it first appeared in forensics discussions from a paper published by Yogesh Katari. So in March 2015, he wrote a paper and did a SANS presentation where he talks about using Shrum for forensics purposes, and it's really interesting. It's a really interesting discussion. So back to some of the details. So it's Windows 8 or above, right? So that's pretty recent. That rules out Windows 7. There's still a lot of companies with Windows 7 running, so that's a shame. It monitors desktop and Windows applications, services, network connections, and historical data, and it carries a historical database. So I'm going, this is really great. I can really use this. This could be really useful. So what can we do with it? So it's always on by default as well. And I'm like, oh wow, this is cool. And I'm like, this is really going to be helpful in terms of doing forensics work, right? Because if you're always on and it's on by default, you're definitely going to have some data in there, right? Microsoft had to make some changes a few years ago where you can actually turn this thing off because it does collect a lot of data and a lot of things like what programs you're using. And it's got a lot of personal information, like which networks you log on and things like that. So sometimes you want to turn this off. But it does kind of slow down. Well, it doesn't slow down, but it messes up some of the Windows reporting aspects. So if you have a bug, you don't get as much information out of it. So essentially, Shrum provides us with application resource usage, Windows push notifications, energy usage, network connectivity, and network data usage. So all of these elements will provide us information about what's going on the system or what's happened on the system because it's historical, right? So what do we get from the network? Well, from the network, we get an interface type and an ID. So we can pull it back to like a Wi-Fi connection or a LAN connection or a VPN connection. You have a network profile ID. That'll give you things like when you connect to Wi-Fi and if you connect to, say, Abertay University, you can pull that out. So you'll know all the Wi-Fi networks that the machine's been on. It carries bytes uploaded and downloaded. It carries the process consuming data, including the user's SID. Right? Think about that. If I can see which process is doing the most network activity and I know that it's associated to user XYZ, I can start profiling what the user's doing. Or I can look for non-standard accounts doing network activity. So what's one of the key things that you're doing when lateral movement or when you're exfiltrating? Exfiltrate as an attacker, you basically try to create an admin user on your machine, you run a bunch of processes, and you start to exfiltrate data over the network. So if I can now go back and associate that with the historical data and see that a recently created admin user or a non-standard admin user in my environment starts uploading data, it becomes really interesting. It doesn't provide, however, endpoint IP addresses, it doesn't provide ports, and it doesn't really specific network activity. So you won't see things like I'm going to www.google.com or I'm going to www.pornhub.com and downloading the latest malware. What does the application provide? The application provides essentially everything that you need to know about an application. So CPU cycles, context switches, I/O reads and writes, number of read operations, number of write operations, number of flushes, and it also provides user information. So again, if we can associate an application being run by a user, we can see who ran the application. When you're working in corporate environment, I know some of you have probably run into this, is you're sitting there, you thought, somebody's run something. You're sure somebody's run something. And they're like, no, I didn't run this. No, I didn't run this. With this, I can actually demonstrate that the user ran the program because I can reassociate the launch of the malicious program to a user ID. And that becomes really interesting because you can actually tell the user, well, you did actually run this, so where did you find that application? It doesn't provide memory type information though. So you won't be able to get anything out of that's associated to the memory, to number of threads, number of handles. So anything like DLL injections or reflection attacks, you won't be able to see. But I don't really care about that. I just want to see what processes have been running and what processes have been used by which user. So there's another aspect to which was the application history. So when you're on Windows 10, you can actually see this. If you go into the task manager, there's a tab called application history, and it shows you all the applications that are run on that system. And the interesting thing is you have a show history for all processes. And what happens when you do that is you actually see processes that have run over time, and you can start to see processes that have been uninstalled, or applications that have been uninstalled, because those are still in the database, but it's creating. So you can see when an application was installed, say like a dropper, gets installed, runs, and gets removed. So you're going to see that process in this application history, which is interesting again, because how many times if you do forensics and you're like looking for that freaking application that actually installed the malware, or how that malware got onto the box. So how does this work? Well, essentially, the policy service has a bunch of DLLs. It's like 5 or 6 of them. So they all monitor things like data usage, application usage, energy usage, and Windows environment information. That pushes stuff into the registry. So those DLLs will collect the data, push it into registry, and then after a certain amount of time, 1 hour to be precise, it'll be dumped into a DAT file. Okay? So the first step in this is you have a registry extension called under Windows NT current version SRUM extensions. So you actually you can see that all of the DLLs, they're all based by GUID, and under that you also have the temporary data that gets stored. So this is one part you need to access. And I'm like, okay, this is good, because I can access this. I mean, PowerShell can directly access the registry. So I'm good. I'm still good. And it gets written to disk every 60 minutes. The second part of this is the database. So the database, which is stored in Windows System 32 SRU-DB.dat, is an ESS, so Extensible Storage Engine. The Extensible Storage Engine is essentially a database that Windows started using with Active Directory, Windows updates. It stores all the information that it needs to basically run the operating system. You also find it with IE. If you're doing IE cache work, most of it is stored in this ESS database format. In that ESS database format, you actually have a bunch of tables. One for network connectivity data, one for application resource usage, one for network usage data, Windows push notification data, and energy usage. So energy usage actually covers things like how much CPU cycles and how much power is being drawn, battery life, and things like that. The one problem with this data format is that you actually do have a lot of fields that have weird formatting. So you have 2 types of timestamps, which is a pain, because you have to mess around with 2 types of timestamps. But they're in UTC format, which is nice, because usually when you're doing forensics, you want UTC format anyway. You've got a bunch of GUIDs, and you've got, for the network, you actually have to go back and calculate. You get a structured data. So you need to pull out the information from that structured data, then reassociate it to the registry to actually find out which network interface was being used. That's a little bit more complex. So what's the forensics angle to this? Well, in forensics, one of the things you want to do is you want to understand what the process activity was. You want to build a process map over time. See which processes ran when, what are the dependencies, how much time a process was used. You also might want to see which network usage was being done. So how many times, for example, Explorer connected and how much data it uploaded or downloaded. You want to see which apps have been added or deleted. You want to see which processes run over time. How many times have they run? For how long? Things like that. And I was thinking about this. So wait a minute. If I can associate the process with resource usage, specifically power and CPU cycles, I could start looking for miners. You know, all these script miners that you accidentally get when you go to certain websites and they start eating up your CPU cycles. Well, maybe I could use this to actually see if there was that kind of incident on a machine. So probably something I need to think about. It's not really a focus because most of the times, unless they actually drop something like Emotet, I'm not too concerned about it. But it's something in the background. So typically, when you see attackers, one of the things they'll do is they'll try to hide when they've launched an application. And the way they do that is they mess around with the prefetch files. Essentially, what the prefetch file does is it allows you to see when an application has been run. So when applications are run, it creates a prefetch file so you can actually track when that application was launched by the user. But it only shows the start time. Now, with Shrum, you actually start to see the visibility. Because you've got checkpoints of usage, you can actually see how long WinWord has actually been running, for example, in this chart example. So prefetch will only give you the last 8 start times, but Shrum will actually give you how long that process has been running, which is a lot more interesting, because even if you see a malicious app start, let's say the attacker is a really bad one, he doesn't delete his prefetch file. If you see it start, you also want to know how long it's been running. Because it might start and then just die, right? Because it doesn't connect to anywhere. Or it starts and might hide itself and just continue running until it actually wakes up and downloads something else. So having the ability to actually build these timelines in a more as for the length of time that process has actually been running is a lot more interesting. Other things that we can track is we can map, as I said earlier, a process with a user. So you can actually see which users are running which processes. This is helpful, again, because one of the tactics is to create a special, an admin user, so you can see which admin users are running which processes. You can map process and network activity, so you can actually start to look at exfiltration. One example would be Explorer copying files or uploading files, creating a lot of network traffic at 2 o'clock in the morning. Most users won't do that, right? Especially in a corporate environment. And you can use it to do general program usage investigation. So, one of the things I ran into in my history in corporate environment is that we weren't really blocking or whitelisting applications, but the policy said you weren't allowed to use things like torrent downloaders and things like that. With this, you can actually track when a user's been using torrent downloaders or non-authorized software, which is useful for many large corporations, especially when you have users that have admin access to their machines and they can install anything. So, how do we access this data? Well, the initial thought is you need to access the Shrum.dat. Most of the research that's been done and most of the work that's been done initially, and there's one tool that came from Mark Baggett. Basically, they require you to get a copy of the ShrubDB and then download it, dump it into CSV, and then process a bunch of scripts to create into an Excel. Mark Baggett's tool actually does the extraction and generates the Excels automatically. There's one problem with that, and that's what I don't want to copy the DB. I don't want to have to process the disk, right? I want to do this dynamically. I want to be able to do this fast and rapid and quickly online. If you need to make a copy of the DB, because it's admin locked and because it's continuously in usage by the system, you either have to shut down the machine, or you have to do a disk image, or you have to use VSS to do a shadow copy. So so once you start doing that, you're changing the environment and you're changing things, and you're probably potentially losing any forensics evidence which you might want to keep. So I'm like, oh God, another roadblock. So how am I going to solve this? Well, hold on a second. My initial thought was I'm going to use PowerShell to do all this stuff, right? Yeah, so I potentially have a solution under my hand. So how am I going to do this? Well, PowerShell actually supports .NET, right? So you can actually use .NET APIs and .NET modules directly in PowerShell. You can load C libraries. You can actually even include C code in some versions of PowerShell. And you can load DLLs directly. So all you need to do basically to add a module or to load a DLL is you do add.-type-path to the DLL. And that loads it as a module. And you have access to your API. Is there an API for ESS? Well, from here, yes, of course there is, right? So the good thing is the DLL is part of .NET Framework 4.0. And as far as I know, probably 95% of all systems actually have .NET 4.0 installed. Mostly because it's one of the core MFC classes, but it has to be an application in Windows. Well, one of the baseline applications in Windows will have that requirement. So the exact DLL is in a really horrible path. So Windows, Microsoft.NET, Assembly, GAC Missile, Microsoft.ism, ESN.interop, v4.0, and then the underscore 10 is actually, I think it's related to the operating system you're using. And the file is called microsoft.ism.esnet.interop.dll. Okay, so I have an API to access this database, right? Yes, I'm back to my success factor. Right, I'm cool. No, I'm not. We won't get into that. So this is going to be hard. Let me see if I can actually. Let me do something. Maybe I'll be able to actually zoom in a bit on this. So I can walk you through some code. Give me a second. So let's see if this works. Okay, so no, I can't zoom in. Oh, crap. That's going to be, I know what I'll do. I'll walk you through the, okay, so that's a little bit better, right? Can you guys see that up there? Is it better? So, first line, I'm going to put the path to my DLL into a variable. So for those of you, if you haven't done PowerShell, there's some interesting things, right? For those of you who've done Python, you'll probably recognize some of this. For those who've done Bash programming, you probably recognize some of this. $env is a shortcut, an alias to the environment variables. So you can actually reference the environment variables. So here I'm referencing system root, which is on systems usually C Windows. And then you have the path to your DLL. So all that will be expanded inside the variable. Next, I put the path of my shrub DB, and now I can start accessing the database. So essentially, the database is a JET. You access it with the JET file DB APIs. So what I'm doing here is I'm setting up some variables, file type and page size, -1, and the -1 just says default. Just ignore this value. You'll pick it up when you read the database. So I have add type path. I'm loading my module, right? I then can start to access the database. So these hooks right here is essentially how you access .NET classes in PowerShell. Right? So you basically describe the .NET class that you want, the function, and then for this particular thing, I'm pulling out the variable. So the first command is to get the database file info. So we know what database, if we have a proper database, and then we actually query the database itself. That'll dump a DB type. If you've got the right file, it'll say database. The actual page size, which normally is about 4096, and the file type as well. So then the next step is, like in any database, you have to basically open a session and connect to it. So here, new object basically is a command in PowerShell that allows you to create a new variable that has an object structure. A variable with an object structure is essentially it's like a JSON, if you want. If you know JSON, you have a variable name and the value, and it's in a blob. So you've got that blob with all these data inside. So I'm opening an instance, I'm opening a session ID, and then I can start to pull out some of the system parameters of that database. Right? So I'm putting it into a temp file because it gives out a value. If you ever need to process the value for errors and things like that, that's what you do. You can use a temp file. So then you have to create an instance. So this is a peculiarity of JET databases, is you're actually creating an instance of a connection, and then you're initializing that connection, and then you begin your session. This is well documented in Microsoft's documentation on the JET API. Once you've done that, you can actually open the database. So I'm opening the database with this command, which gives me a database ID. So from now, I can use that database ID to reference the data. I can then attach the database. There's a lot of attaching and connections in this thing. Then you can open the database. So now I have a database ID, a session, and a connect value. And I can actually write that out. So basically, this is PS custom object is another way of initiating an object. The @ symbol also references an object, and then the hooks is the object data structure. So you see I've got instance is equal to $instance, session is equal to $session, database ID equals $base ID, and then the path to the database. I'll show you some of this output in a bit. So then I can get the tables, right? So get tables names. Now we're back into more, standard types of database manipulation, right? So we're going to get the database tables, I can get the database columns, and I can get the database rows. In theory. We'll get into that in a little bit. So, interestingly enough, when I mentioned the DLLs at the beginning and the tables at the beginning, I had like 6 tables, right? When you dump Windows 10, you actually have a few other tables. So, interesting. I wonder what data's in there. That's probably one of the things that's one of the things that Small Mind has to do to understand what those extra tables are. So how do I access these tables? Well, I can put the table name, which is the GUID, into a variable, and then I just connect to the table in the same way that I connected to the database, right? So I'm back my session ID, the database ID, and I add the table name. So now I have a reference pointer to my table. And of course I can connect to multiple tables at once. Right? Now comes the complicated part. So unlike SQL, where you can do select star from table to get all the data, with this API, you actually have to parse each row manually. It's like, oh, crap. And the way you do that is by column. So you have to dump one column at a time, one row at a time. Fun. I mean, who the hell wrote this? So, here we go. I mean, might as well do it. We're here now, right? So, you pull out the columns. Get table columns. And because I'm in PowerShell, I can do some really interesting things. So, try first move tells the Jet API to move to the head of the database, to go to the first row. So now I'm going to do a while loop. So I initiate a temporary row database data structure, so I can capture that row. And now for each of the columns in columns, so columns is the output from the database from the get columns. So $column, I'm just basically grabbing one column at a time. I then need to look at the column type, which is really annoying. Because you've got all of these column types, and depending on the column type, you might have to manipulate the data, like down here, where basically I've got text. Unfortunately, the text has a closing 0, so you have to remove that, any null characters. You've got currency, same thing, you have to remove null characters. And then you've got some weird ones where you basically need to convert a 64-bit int into a date time, because that's what the column does, or is referencing. And then sometimes you have columns that don't have a reference type. Not in these, thank God. So once I have the information from that row for all the columns, I can add my data back into my new table. So what I'm doing is I'm essentially copying Jet database data into a variable in PowerShell. And then you can close the database. So that's how you connect to it. So I will try to do a demo, but I've been having problems accessing. So I do have some screenshots. So one of the problems, the first problem I ran into, so I connected to my database, I got the page size, I got the session ID, I got everything done, then I did an attached database. And Windows just told me, bleh. It actually says cannot access file, the file is locked. So luckily in PowerShell, the window actually tells you what account you're using or what mode you're in. I was in my standard user account. So, oh no. Okay. Let's try admin. Try admin. Worked. Yay! So, once you do that, I basically now have an instance ID. So Jet instance ID, session ID, a DB ID. So DB ID is 1. There's only one database in here, as far as I know. And then the file path. So those are my references to actually access the database. Then I can dump columns. So this is one of the new files, data tables inside that come with Windows 10. And if you look at the field names, the column names, so you've got app ID, you've got audio in timeline, audio out timeline. Then you've got auto inc ID, comp dirty timeline. So there's a lot of information in here, right? And I mean, this table has like 25 columns or something like that. This is the network usage one. This is a lot easier. So I've got an app ID, I've got an auto inc ID, I've got the bytes received, bytes sent, the interface, the L2 profile, the connection profile ID, the timestamp, and the user ID. And this is what's interesting, right? So I can associate an app, a user, a timestamp, and the amount of data that they're pulling in and out. So this is the application usage table. So once you've run that horrible while loop, you basically get this data, right? So I've got the name of the column and a value. And you can see it's 64-bit values, background cycle time. So so you need to kind of figure that one out. So a lot of information that you can process. So how does this fit into hunting? Well, if I have applications and I know which one's being used and I know which ones are running and I know who's running them, I can kind of do application profiling on the fly. If I know network usage, I can start to look for weird network patterns, right? If I baseline my environment and I know that I'm in a corporate environment and most machines don't do any network activity during the night, and I pick up a machine and it's doing network activity during the night, it becomes interesting. So essentially, what I'm getting to is like a mini EDR tool or like a PowerShell version of OS Query to a certain extent, which is fun. I mean, I don't need to install anything. I can just use these commands and just start dumping data off a Windows box. Fun. The good and the bad and the ugly. So this is still, I haven't had as much time as I wanted to really work on this. So I'm going to have to automate the data processing. Right now I'm doing it manually to a lot of extent. I want to see how I can do this remotely, right? You can actually connect PowerShell remotely using WinRM, but that means that you have to have WinRM enabled in your environment. And I want to build a module which I can automatically just pull and download and install, which I haven't been able to get to yet. Module building is almost like building an API library, if you want. So you have to give it a certain structure, you have to give it certain commands, and once you've done that, you insert it as a module, and you're essentially adding commands to PowerShell. There are implications on PowerShell versions. So most of the commands I'm using won't work if you have a PowerShell earlier than 3.0. The Windows servers does run diagnostic policy services, but I have yet to figure out where the StrumDB is. There's a specific switch that you need to turn on in Windows servers to actually get the StrumDB to work. And I'm still working on that one. And I'm probably going to run into a whole bunch of other issues over time, right? So I will publish this code at some time. Right now it's a private repo because it's really ugly and there's a lot of mistakes in it. So I'm not going to, if you want access to it, you can come and see me. I can provide you access. But that's the URL. That's how you can get in touch with me. Now, I want to see if I can do a demo, which is going to be interesting. So you have to bear with me for a bit. What? I might have fallen asleep. Okay, so I don't think this is going to work, but we'll try anyway. So first, I've loaded the DLL into... You can't see it? Okay, I thought I made it big enough, but I'll make it bigger. Better? So first I basically loaded the DLL into a variable. So now I'm going to put the database into a path as well. Okay. I'm going to set my variables and pull the module, the DLL into the memory. So now I can connect to the data. Well, I can get the database file info. What am I missing? Ugh. It's the problem when you're doing this remotely. Okay, so now the database, the DLL and the API are loaded into memory. So now so what I've done right now is I'm querying the database file to see what the page size is. So I can actually do $page size. So just by typing the variable name, I can get the output. So I know that page size is 4096. It's not really pertinent to what we need to do, but it's useful to have. It means you're connecting to the database. And you also need the information later when you want to actually connect to the database itself. We can get the file type. Crap. I gotta start all over again. Sorry, I gotta start all over again. Okay. So we got page size 4096, file type of 1. And now I can open my database session. Okay, so I have a session open now. So if I do a $session, so actually I don't. So basically the $session, when you look at it, gives you a value of true or false is invalid. So when it's true, it means you're not connected to the database, or you can't connect to the database for some reason. So we're not going to go very far, unfortunately. See if I can connect VNC on this one. Is there any questions while this tries to connect? Was it too technical for this early in the morning? I've been working with it, but I haven't found anything yet, because most of the images that I've been looking at were essentially clean. So I need to improve the demo on this. So probably what I'll do is I'll actually infect a few machines and then pull out the data and do it that way. One of the biggest problems I'm having right now is actually processing the data, because as you saw on that screenshot earlier, it's a lot of data and it's historical data. If the thing's been running properly, you've basically got data all the way from the start of the installation of that Windows 10 box, for example. So you can have a massive amount of data. So processing it becomes more complex. Plus you have to I'm still working on pulling out the right information to then associate it back to the registry keys. Because, for example, like the user ID, you have to associate it back to the user, which is an index inside the registry key. So you have to go into the registry key, pull out the user. You have to index it into the registry key in the user, under the user profiles to get the actual user ID. So there's a lot of manipulation that you have to do in the background. And that's where some of my scripts are failing, because either I'm pointing to the wrong place or I'm just not referencing it properly, and it's taking me time to actually, basically what I'm going to have to do one day is just draw it out, right? Draw the links and draw the lines together, map it out. But time constraints have basically let me down. Yeah. Yeah. So summary of the question is, can we pull all the information together to I'd say baseline your environment to look for indicators or to pull out indicators? That is a really interesting question and probably very hard to do. And I'll explain why. Because you're actually tracking application usage. Like, you might use Word and PowerPoint and Excel one way, the person to your right may not, right? May use it in a different way, or may never use Excel. So how do you baseline that across an organization or across a pool of computers? You can't really, because you're never going to have the same usage patterns. So what the idea I had in the back of my mind, once I figured out all the data problems and all the associations and how to actually pull this dynamically, because I'm having problems with the database connectivity as well. It can time out, especially when I'm trying to pull out the data. I was running it yesterday on one of my machines, and it had been running for like an hour and it was still processing the rows. Okay. So it's not very efficient. So I need to find a way to make it more efficient. But long term, the idea would be to maybe do something like, like Yara, and have a set of prefix datas that I can point to the script, and the script would actually go looking for those types of indicators, right? But you wouldn't have, you could essentially build it, because you can use PowerShell to pull out hashes. So you could actually look for a process with a certain hash and then dive into this database and see how many times it's run, or see when it's run, how long it's run, and what the network activity was on it. But it's a very complex process, and to a certain extent would require crap load of development. And point is to search. But you missed the point. You can't build a baseline on application usage. On user application usage. This is user application usage. You can't build a baseline because no user, unless we're talking about a bunch of robots, you're never going to get the same usage. So essentially, that's there's many directions this could go in, but I need to optimize the initial code first. Until I optimize that initial code and actually have a module that I can just pull in when I need it to actually do that search, to do that query, I'm not even thinking about the possibilities, to be honest. But I'll note it down and I'll run it. And I'll keep it in mind. You could. So the question is, why search in PowerShell? Why not drop it to something like Spark or upload it to your SIM and things like that? You can actually. So in the same way that I can pull stuff off the net, I can actually create a connection and do, query an API or post things to an API. The idea was I wanted something, let's be honest, a la OS query, right? Where basically you have the ability to run some kind of script or some kind of shell, and you're just querying dynamically live on that system. Because it was more about finding things rather than keeping a constant baseline or keeping a constant inventory of what was running on the machine. Because then, in Europe you get into certain shady areas on privacy issues, right? But you can detect things like Tor browsers running, right? Tor connections. You can find the VPN connection will show up as an interface and a network profile. So if anybody creates a VPN, you can actually see it. I think we have time for maybe one more or two more questions. Up top. I'm probably just I'm going to eventually write a module, but so let me back up. The question was, will I publish this module on PowerShell Gallery? I'm going to write a PowerShell module. I'm probably going to leave it in GitHub because I want it to be maintained in that way. And if you look at a lot of the stuff that Microsoft is actually doing around PowerShell, it's all in GitHub now as well. So for those of you who haven't seen me before, I actually work on a Pixelbook. That's weird. Oh, crappy. So on the Pixelbook now, you have like a Ubuntu VM. I actually have PowerShell installed on this because Microsoft has open source PowerShell version 6, and so if I go, I think it's. So I've got PowerShell 6 on this machine, and it's a Pixelbook, right? So they've done a lot of that work is now in GitHub, and I'm just going to leave it there, to be honest. So then people can use it the way they want to use it. Cut. Well, thanks everybody for coming. I hope you didn't get too scared of you like the talk.